Hi, everybody. Let's start with the prayer. In the name of the Father, Son, Holy Spirit. Hail Mary.
All praise
The Lord is with thee. Blessed art thou amongst women, and blessed is the fruit of thy womb, Jesus.
Holy Mary, Mother of God, pray for us sinners now and at the hour of our death. Amen.
Great. Last time we had talked a little bit about sections 1 and 2. I think I told you guys you could have been able to do up through problems 4. Any questions on anything so far? Should have been relatively straightforward things, right? Yeah. Okay. Well, I'm going to pick up where we had left off in section 2. We'll wrap that up. We'll do section 3 and probably section 4 today also. 3 is a kind of an almost nothing burger of a section for us, so we should be able to handle that. Just to reiterate, that's going to be the typical start to every class where I ask you guys if you have questions on things. Could be homework, could be content, could be whatever. If you have questions on stuff, we're baking in time at the start of every class to deal with those things. If you didn't get a chance to come find me some other time, that's a great time to just be like, hey, I didn't know what to do with number 18 or whatever. Like, can we talk about that? And we can do those sorts of things. Okay? Yes. Olivia.
Yeah. Is that what really graded on completion?
Correct.
Okay.
Not right and wrong.
Yeah, okay.
Yeah, no problem, dude. Happy to answer those sorts of questions. Okay. So in 1.2, we had talked about interval notations, right? We went through some examples of how to take a set and turn it into an interval notation. What we still need to do in this section is talk about domains and ranges, or finding domains and ranges. And this was something you would have done in your Algebra 2 class, so it shouldn't be unfamiliar. Remember that a domain is this, for a function, is the set of values of x that give you an output, right? So up into this point, what is there? There's probably like 3 things that can give you an undefined, or 3 operations that you have that can give you undefined, right? Does anybody remember what those 3 occurrences are? Or even one of those 3? So from Algebra 2 or earlier, there's like 3 things that can happen where you try to do something to 2 numbers or a number or whatever, and it comes out undefined. Does anybody remember any of these things? Nolan. Other way around. If we divide by 0, yep. Yep, that's a good one. Right, that gives you something undefined, or doesn't have a real number answer. Everybody's cool? I'll give you a hint. What if you have the equation x squared equals -1?
Oh.
Does that give you a real numbered answer? It gives you an imaginary result, right? So what is the takeaway here? If we square root negative, yeah. So square rooting a negative. And the third one is one you might not remember. What's the least understood part of Algebra 2 typically for an Algebra 2 student? What topic did you do last year that was like the one that you're just like, I'm not so sure about that when I finished? It's logs. Everybody always says logs. That's the thing that I'm like, it's like, I don't, like we did it, and I kind of knew it, but like I don't get it. Right? Oh, you liked them. That's good. How can I, the log of what kind of numbers give us negative, or give us undefined? Natural log of what kind of number? So non-positives. Log of 0 is undefined, as well as log of any negative number is undefined. Everybody's okay with that? Because I know I can't do like b to some power and it can't give me 0, right? And it can't give me a negative, right? That's a ridiculous thing to claim, right? So those are the three things that we have to watch out for when we're looking for the domain of a function. We have to worry about, hey, can we divide by 0 for any value of x? Does a value of x mean that I'm going to be square rooting negatives? Or does it mean that I'm going to be taking a log of a non-positive? So these are the three cases to watch out for when we're looking for a domain. So I'm just going to give you, okay. And then there's really two types of domain, right? There's your implied domain. And you get your implied domain just from the equation of the function. And then you have the relevant domain, which uses the equation and context. And the relevant domain is sometimes a little trickier because you have to think about it. Oh no. But we'll do some examples and it'll be okay. It's not so bad. Once you see it and see the example, you're like, oh, okay, sure. Makes sense. Let's go ahead and grind through a couple of these guys. All right. So let's say we have the function f of x equals 2 times the square root of x minus 4. Is it possible that a value of x is going to imply that we're dividing by 0 here? Not a trick question. No, right? There's not even any division in the function. There's no way I'm going to be dividing by 0 for a value of x. Everybody's cool? Is there any possibility I square root a negative? Yeah, I have a square root symbol with a variable underneath it. You're sure as heck tootin' there better be a possibility of square rooting a negative. Is there any way that I take a log of a non-positive? No, there's no log in this function. That can't happen. So the only thing I have to worry about is square rooting the negative. So to find the domain for this function, I should say the implied domain for this function, I just need the stuff that's under the square root to always be non-negative. Everybody's okay with that? If I restrict the values of x in my domain to be, well, in this case, greater than or equal to 4, I'm never going to be square rooting a negative, so all those values of x should lie in my domain. Everybody's okay with that? A yes or no would be okay to say there if you're good. Okay. I'm not trying to be cheeky or anything, but maybe it's a little bit cheeky. So if I draw my number line, this would look like this, right? So if I wanted to write my interval, my lower bound is 4, and my upper bound is positive infinity. The 4 gets a bracket because it was included in that set, and the infinity gets a parenthesis. And for clarity's sake, because now we're talking about a domain specifically as the set, I'm going to say x is a member of that set to make it clear that the set is a domain. You could also just say it in words, like the domain is. that, and that would be fine as well. Is everybody okay with what we did there?
Yes.
And note that since there's no context to this problem, the implied domain is the same as the relevant domain.
Correct?
Yes.
What you said for the X.
So that just means X is a member of this set. And I put that in here because the set we're describing is a domain. So the domain is all of the values of X that are in this set. Because if I just list the set and I don't say what it is, it's like, is it a domain? Is this a range? Is this something else?
So if it was a range, I put a Y.
Correct. Or you could say in words, like the domain is that, and that would be okay too. We're just talking about making sure we communicate. Because if I ask you to list the domain and range, tell me which one is which, like, I don't know if you know the difference between the two, right? So you could do that either way. You could do it with words or you could do it with symbols. Now, one of the goals in any math class is to build out your math communication skills. So I'm going to do things both ways. We'll say it in words and I'll often write it with symbols. You're not required until I tell you you're required to use symbols when you could use words. But I'm just kind of trying to build out your math communication skills, right? Writing, saying, reading, communication. Cool. And again, if you're not sure what a symbol is or what I said, or if you missed it because I was talking fast, because sometimes, you just had a soda pop real quick and you're kind of jittery. No, nobody gets like that? Okay. But you can ask me to slow down or repeat or any of those things, and that's okay. All right, next one. Okay. How about this g of x equals 3x over x plus 2? So from our list, is there any way that I could divide by 0?
Yeah.
Yeah, right? We have an x in the denominator. You're darn tootin'. To ensure that that is not 0, I just need to make sure that x plus 2 is not equal to 0. Now, could I ever square root a negative? No, there's not a square root symbol in here, dummy. Oh, okay. Could I ever end up taking a log of a non-positive? There's no log function on there, dummy. Oh, okay. That's easy then. So we just go ahead and we subtract 2 from both sides. And then we want to write this or on the number line. Is this obvious what to do here? What would this look like on the number line? I know I'd have an open circle at 2 because 2 is not okay. And then everything less than 2 would be okay, or everything bigger than 2 would be okay. Everybody agree with that? Now to write this as intervals, I'm going to need one interval for that arrow and one interval for that arrow. Is that okay? So the first interval is going to go negative infinity to negative 2. Again, I use parentheses every single time for all infinities. And I use the parenthesis on the negative 2 because it's not part of my set, not included. Everybody's doing okay? And the other interval is negative 2 to positive infinity. So again, that's going to be everything except for negative 2. And I wrote x as a member of that set, or you could say the domain is Nolan. So not if you're asked to use interval notation to write the domain. So it just depends on the direction. But yes, you could describe that as a set. And if you wanted to, you could say like, if there weren't directions stating to use interval notation, you could be like, you write like that. So the set of real numbers except for 2. But that wouldn't be using interval notation. So if the directions were to write the domain using interval notation, it's the correct domain, you just didn't follow the direction kind of thing. You know what I mean? So it's like it's right, but you didn't follow the directions. But yeah, you could think about it that way as well. That's not incorrect, other than you avoided the notation we're asking to use. Not a big deal. Let's do this next one. So V of S is equal to S cubed, where V of S is the volume of a sphere with side length, or I should say where S is the side length. Notice here, we have some context along with our formula, right? So here the implied domain and the relevant domain may be different. They don't have to be different, but they could be. So far, so good? Okay. Let's look at the implied domain first by just looking at the formula. So S cubed. Does that involve dividing by 0? Square rooting negatives? Logs and non-positives? So what should we say the domain is? All real numbers. So the way we write that using interval notation is negative infinity to positive infinity. Everybody's good there? Now let's worry about the relevant domain. So what we're worried about is we're concerned with the S, right? Since that's the independent variable. So if S is the side length of a cube, what kind of numbers is it okay for S to be? Positive, right? So we would say S has to be greater than 0. So if you translate that to a number line, you're looking at something like this. So your relevant domain would be the interval from 0 to positive infinity. Easy, right? It requires you to think a little bit about it, but, it's usually not too hard to think about it. Yes. So the relevant domain only happens if there's a context provided to the problem. So like if the variables actually have a real meaning, if they're not just variables, right? If it's not just abstraction, if it's actually like describing something in the real world, right? So if we just ignored the context, we would have said the domain is all real numbers. But if we're actually talking about a cube, well, the side lengths of the cube, they can't be negative. They can't be 0, unless you want to define a single point as a cube. I don't think I'd want to do that, but maybe you want to call something that's not there, like maybe that wants to be part of your model. I wouldn't mark this right or wrong. This is like unclear from the context, but maybe something that's not a cube has volume 0. It's like not there should have volume 0. Maybe you'd want to include 0 so you could have a 0 volume shape. I don't know. It would depend on like what you're going to do with this, I guess. I wouldn't be too picky about that. Either way you did it, because I don't think there's enough information for you to make a judgment call one way or the other, but as long as you're consistent with what you did there. By consistent, I mean like, that this thing and matches that thing, right? Is that okay? You guys get what I'm saying? Okay. Let's do one more bonus one. It's maybe not in the not from the notes. Uh-oh. All right, let's find the domain of this one. Is this a little bit more complicated? Yeah, why is that? Yeah, because we got a divide by 0 situation. And we have a square rooting of negative situation. Everybody kind of see that? What does that mean for us? Well, I'll show you in a moment. We'll go ahead and draw these both on the number line. I'm going to draw this part in green, and I'm going to draw this part in blue. Is everybody cool? Figure I should color code this. So not equal to 2. Looks like this. And then greater than negative, or greater than or equal to -5, looks like this. Does everybody feel good with what we've done there? Now, because this is an AND situation, I'm now going to look for the overlap of the green part with the blue part. So those overlap here between -5 and 2, and then here again after 2. Does that all look good to you guys? Okay, so now all I have to do is translate this into intervals. How many intervals am I going to need? 2. So from -5 to 2, or from 2 to positive infinity. That look okay? Yeah, not bad, right? Not bad. All right. Any domain questions? So if we're looking to find a domain algebraically, this is kind of what we're asking you to do, right? You're just looking for parts where you might square a negative, or divide by 0, or take the log of a non-positive. I don't think you'll see any logs in the homework. Maybe you will. I don't remember anymore. It's possible. It's been, I mean, I've done all the homework problems at one point or another, but like, do I remember what was there still? No, I don't. Yeah. All right. Ranges. Is this going to be easier or harder than the domain? Harder. Harder. Yeah. So, what is the, why is this going to be harder than finding a domain? Because it's going to depend on 2 things. It's going to depend on what the function is doing and then what the domain is. Okay? So, our best case scenario is when the function is only doing one thing. If it's only increasing or only decreasing, that's not going to be bad for us. Should be relatively easy to find out. If it's doing both, that makes life a little bit more complicated. Okay? Do you remember what we mean by increasing and decreasing? Increasing means if you read the graph from left to right, you're always kind of walking uphill. Decreasing would be if you read the graph from right to left, you'd be like walking downhill. Imagine you have a little man walking along the graph. I should say a little person. Let's be gender neutral. No? We'll get it. We'll draw a picture here. So let's find the range for these first three things. We're going to avoid that last one because it's an awful looking mess. Okay, so I wrote down the domain that we had found earlier for this because I kind of need that. So the first thing I'm going to do is I'm going to go and I'm going to draw the graph on my calculator for my function. And I'm just going to use my eyeballs to determine if this thing is increasing or decreasing or both. So there's my graph. What do you guys see? Increasing everywhere. Everybody agree with that? If you imagine you have a little person walking along the graph, they're always walking uphill. It's going to be a long walk for that little guy. That's supposed to be funny. I failed. All right. So this is increasing everywhere. So that's going to mean that my range, the lower bound should be f of the lower bound from the domain. And the upper bound for my range should be f of the upper bound from my domain. So the lower bound for my domain was 4. So f of 4 that just gives me 0. Is everybody cool with that? Let's say I have infinity minus 4. What's that? Infinity. Square root of infinity is 2 times infinity is infinity. Is that okay with what I did there? Now the last question that remains is, do I use brackets or parentheses on these? And it's very easy. So the bracket on the 4 means that on f of 4, we would use a bracket. And the parenthesis on infinity means that on f of infinity, we would use a parenthesis. Does that feel okay to you guys? Rita.
Wait, how did the infinity? How do I solve the
Infinity minus 4?
Oh.
Still infinity, right? Square root of infinity, still infinity. 2 times infinity, still infinity.
Yeah.
So I have infinity. Everybody's cool with that? Really, the only thing you'd have to be worried about is if you end up like infinity in the denominator, because now it turns to 0. Right? Like 1 over infinity is 0. Because as the numerator stays the same and the denominator gets bigger and bigger and bigger, the number is getting closer and closer to 0. Right? Like what's bigger, 1/2 or 1/3? 1/2. and then 1/2 or 1/4, or 1/3 and 1/4. As the number in the denominator is getting bigger, the number is getting smaller, closer to 0. That would be the only other place to worry about.
What if you had to group like 3 number segments together? Would you use like 2 U's?
Yes, you could use lots of U's if you have like 3 segments that you might need to connect together. Sure. Yeah. And that could certainly happen if you have like a quadratic in the denominator or something, right? Where you have 2 numbers that you have to throw out. Yep. Is everybody okay with what we've done here? So we just use the graph on our calculator to determine where the graph is increasing or decreasing. And then we used the boundaries from our domain to do from there. What was this? This was like 2x over something or another. X plus 2, I think. Is that right? No, 3x. That's what it was. And then our domain here was this. Okay. Step 1, we're going to look at the picture. So I'm going to use the fraction command. I'm going to do alpha y equals, and then press option 1, because you need 2 sets of parentheses if you're going to type this in with just the division bar. And to me, this is so much simpler, right? If I can just type it exactly the way it looks on my calculator, that's nice. Okay. So if I look at this segment of my domain, the negative infinity to negative 2 piece, that's this part of the graph, right? Is that part increasing, decreasing, or both? All increasing. Everybody agree? If I look at negative 2 to positive infinity, that's this section of our graph. Is that increasing, decreasing, or both? Also increasing. Everybody cool with that? Okay, both of those are increasing. So I can go f of negative infinity, comma f of negative 2, union f of negative 2 to positive infinity. Oh, boogers, that's not what I want to do, is it? Because that's going to come out undefined. What do I want to do there? Why didn't it work? Oh, no, it'll be okay. Yeah. One moment. Okay. Yeah, this is fine. This is fine. Okay. Unexpected order, but that's okay. This is good. Okay. All right. Everybody's okay? Plugged it in. I just wanted to double check before we got too far. I'm like, did I screw something up? And I didn't screw anything up. It just was coming out in an order I didn't expect. That's okay, though. It's still the same thing. Okay, so let's plug in. And actually, I'm just going to, well, I might as well. It's fine. Everybody's okay with what I did here? Okay. Now, infinity arithmetic. Not trivial. So 3 times negative infinity. I'm going to write as negative 3 infinity for a moment. Because what I don't want to end up with is infinity over infinity. Negative infinity plus 2 is negative infinity. Right? Right? That part I'm fine with. Why is this other piece being a booger? Okay, let's just keep going. So I do this, and like negative signs can cancel, infinities can cancel, and I'm left with 3. And I can do the same thing then obviously over there, except it's going to be, all right, right? Everybody's okay with that? Okay. So the next piece gives me negative 6 over 0. Is okay there. When I divide by 0, what's happening? It's undefined. In this case, though, if we think about dividing by 0, what are we heading towards? If I take 5 and divide it by 1, and I do 5 divided by a half, and I do 5 divided by 0.1, and 5 divided by oops, I guess I did 0.01 there. But if I keep getting closer to 0, what do we see happening? It's getting bigger and bigger and bigger. We're going to infinity. Or what else could have been happening? What if we were coming from the other end and we started with like negative 1 and started getting closer to 0? Could be negative infinity also. Is that okay with that? So here, if we're starting at 3, what does this have to be? Negative infinity or positive infinity? Positive. Because we always write lower bound, comma, upper bound. The thing on the right has to be bigger than the number on the left. So this one has to be positive infinity. And then over here, if we have something comma 3, what has to be on the left? Negative infinity. This was why I was like, wait a minute, what's going on? Because I had them in the order I didn't expect. Right? I had the... So if we go back and we look at our graph, makes sense when you look at our graph, right? if I look at this chunk that was attached to negative infinity to negative 2, the y-coordinates here are 3 to positive infinity. That's what we saw down here. If I look at this piece of my graph that was attached to negative 2 to positive infinity, the y-coordinates there are negative infinity up to 3. So I was just surprised when I got it, because we wouldn't write it in this order, right? We would start small to big, but it's not incorrect to write it in this order because we haven't flopped the individual coordinates. We just have the two intervals in an order that's like you wouldn't expect, but it's not incorrect, right? Remember, the intervals are describing like the numbers between, all the stuff between two numbers. So you can't have big to small because there's nothing in between that. But the two intervals you're joining together with a union, it's just saying like all of the stuff, right? Which is fine. If you start with the small stuff and then you have the big stuff, you're just saying all of it. Is that?
Yeah.
Okay.
So why is 1 infinity positive?
Right. So why is that? Why is 1 infinity positive and the other negative? Why is dividing by 0? Because it could be either one. And we don't know what it's going to be just by doing like 5 divided by 0. Could be positive, negative, or positive infinity or negative infinity. You're going to pick so that it fits in the interval correctly. It does matter.
Yeah,
But like either could be correct.
Yeah.
It's just going to be like what makes your interval correct. You know, which is a little unsatisfying because it's not the same every time. But it's also why I did the ones that didn't have the infinities first. So I knew. But if you think about it, can I ever have a negative infinity here in this spot? No, it always has to be positive. And just like this spot, could I ever have a positive infinity in that spot? No, the negative infinity have to go there. So it's just like, right, if you have an infinity in the upper bound position, it must be positive. If you get an infinity in the lower bound position, it must be negative. Does that help?
Yeah.
Sure. It's like, that's a better way of describing it. We're going to get there eventually. Paul. Certainly. No problem. Giselle. Giselle. I don't know why I want to make that a Y.
Here we go.
It's because of the Yaldo part, I think. I just see the two letters and they switcherooed in me head. Now I'm a pirate.
Is the reason you can't use 0 because like if you replace the positive infinity with 0, it wouldn't be like the bigger number on the right bound?
Why I can't use
Like
0.
be like 0. So it always has to be infinity. Like if you're dividing like -6 divided by 0,
Yes.
it has to be an infinity.
It'll be either positive infinity or negative infinity.
Depending on if it's right bound or left bound.
Yes.
Got it.
Usually we say upper and lower bound, but I knew what you meant.
Oh yeah.
And I guess I should put the Y as a member of there to box that out. Yes, Sophia.
Let's say that we were gonna find the range of all real numbers. Like graph all the numbers.
Let's do the next one because the implied domain was all real numbers. The relevant domain was something different. But let's start with that. Okay? I think that'll cover exactly what you're asking. So we'll just take a look at x cubed. Okay. Increasing, decreasing, or both? That's all increasing. Right? Here, let's do this for you. Just turn that axis off. Right, it gets flattish, but it never starts going down. Everybody's cool? Everybody, we agree now, no decreasings? You can see it now, right? Okay. So again, we're all increased. Yes, Rita. The -5 and the 2. I think you're looking at D and not C. Is that what was going on? Okay. Talika. Oh. It looked like a hand. Let's see. Come on. Google pen. Okay. My stylus doesn't like me. Do you ever use OneNote and just all of a sudden your stylus just like stops wanting to work? Yeah, I find my fix for this is usually just like take the battery out and put it back in and see if that works. And in this case, it's not working for me, so I'm getting upset. Gigi.
Why is it 0?
So this was our example C. So I'm just doing the range now for each of the 3 examples. So I'm just using my answer from before. Is that okay? Okay. Caitlin. Of course. Yeah. And how come none of you guys yelled at me for doing this? Those should be S's, right? I mean, that's such a small detail, but like the details matter. Well, did I write X before also? I probably did, like a dummy. I didn't? Oh, good. Yeah, I'm on one today, guys. All right. So we saw this was always increasing, and now it's doing this thing where I don't have to touch the screen and it's writing still. Does that happen to you? Kinda. Sure, that would be helpful. I don't know why it feels like at least once a day this goes through. Yes. Get out of here, Microsoft. Take your stylus and go away. Okay. We saw that this was increasing everywhere. So if I look at the range, for an implied range, we would just have f of negative infinity, comma f of positive infinity. So that's going to be negative infinity cubed. Oops. And then positive infinity cubed, which is just negative infinity, comma positive infinity. Everybody's cool with that? So we'd say phi of s.
Yes.
So Sophia, that was your question, right? If the domain was all real numbers?
So it's just
Yeah. Let's see the relevant domain now. How's that? Squeezed it so it's all on the screen there for you guys. Okay. How are you feeling? It's a good question. Okay. Sophia?
I just have another question. So what if it's
Sure.
not increasing?
Yeah. Great. Decreasing, right?
Yeah, or like increasing and decreasing for parabola.
Yeah, let's do it. Sound good? That would be what I would do next. Anyways. Oh, I think I have a different letter. Okay. So let's say we have this. All right. This is a parabola. I'm just going to write down the domain for it. But hopefully nobody's surprised by that, right? Since you can't divide by 0, there's no radical, there's no log. Got to just be all real numbers. Yes? In general, from Algebra 2 last year, you should recognize this as a polynomial and know that the domain of all polynomials is all real numbers. That's a helpful fact to remember. Okay. Now, if we go and we look at this quadratic here, oh, better turn my axes back on. I'm probably going to want those. So 2x squared plus 4x plus 1 graph. So if we look at that, Sophia, we notice that part of it's decreasing and then part of it's increasing. Right? We all notice that? Right? We're downhill to start, we get to the bottom, and then we start going back uphill. So what we need is, where is this thing increasing to? And where is this thing decreasing to? Now, I can tell that it's going, well, it's decreasing to start at negative infinity all the way up into the bottom of the U. And it's decreasing. I wrote that backwards, didn't I? We start out decreasing, and we go increasing. My apologies. A good thing I started repeating myself there. I would have really goobered this up pretty good. Does everybody agree kind of with that? Okay. So what we need to do is figure out what that point is where the graph changes from increasing into decreasing. Or decreasing to increasing, I should say. What's the name for that point? It's the vertex of that parabola, right? So I'm just going to call that Vx for the x-coordinate of the vertex. Everybody's cool? Who remembers how to find the x-coordinate for the vertex of a parabola? No, the formula. We did it last year, or well, you did it last year. That would be negative b over 2a. Does that look familiar now that we see it? Yeah, that's okay. You didn't need to remember. I remembered for you. Yeah, no problem, dudes. Everybody's cool? And I think probably the way I'd want to think about this is I think I want to think about it this way. Right? I'm going to think it's decreasing all the way down to that point, including that point, and then increasing, including that point all the way on. Or else we're going to have a hole. And I don't want a hole. Right? There's no holes in this graph. Everybody agree? Okay. All right. So this is really then -1 here in both spots. Cool? Sweet. All right. So let's do the range then. The decreasing part, yeah, that's just all we did was figure out like where's the domain increasing and where is it, or decreasing and increasing. We still need to do the range now. That only took a long time because we had to like I was explaining carefully what we were doing there. If you remembered the equation to find the vertex, it would take in 10 seconds. You know? But it's okay. It's okay. That's why we're doing this together. Why we're talking through it slowly. Painfully slowly in some cases. That's okay though. I don't mind a little bit of pain inflicted on you guys. All right. So I'm going to call this like D1, and I'm going to call that D2. Yes.
On the vertex, can you just like look at the calculator? If you can like tell what it is.
What if it was like a kooky decimal, though?
But if like you can tell, do you have to like show that word?
Yeah. I mean, I guess not, but like, what if it was, what if it was like 4/3 was the point? Like, or 13/26, no, 27ths. 13/26 would just be a half. Yeah, that was, thank you for paying. Yeah, that's a good call. Mr. Kulik just was trying to pick something arbitrary and then it was too easy. You know what I mean, though? Like, that's what I'm saying. So you just have to be, you should be able to do it if it's inconvenient also. Okay. All right. So what I'm going to do, so I know the domain is equal to just D1, union D2, right? If I take those two halves of the domain and union them together, I get the whole domain. So it stands to reason then the range is going to just be the union of R1 and R2. Everybody's okay with that? Yeah. So the domain is just going to be the union of this piece with that piece. If I join them together, that gives me the whole domain again, right? So if I'm going to calculate R1 from this piece and calculate R2 from this piece, if I join them together, it should give me the whole R again, the whole range. Does that? Yeah. That's just kind of what I'm trying to notate here. Does that make sense though? If I take the range for each piece and I union it all together, that should give me all the Y values. Okay. I just needed a way to like notate them. All right, R1. Here's the tricky part. This is decreasing now. This is the first time we've seen a decreasing piece. So it's going to be, I guess this is K. I should use the letter so it doesn't get confusing. K of the upper bound from D1, comma, K of lower bound D1. Oh no, Mr. Kulik. The order switched when I had a decreasing. So that's why I have Is that okay? And that would give me -1. And here I have how do I want to do that? All right, I'll just do it this way. Okay. 2 times negative infinity squared minus, was that minus? No, plus. 4 times negative infinity plus 1. Everybody's okay with this? I just plugged them in. Isn't that the coefficient? Right? That's all. That's the 2 you're talking about, correct? Okay. Yeah, it's just the coefficient from the function. So I have like something like this, right? Just doing like silly algebra. What is bigger? 2 times something squared or 4 times something? 2 times something squared if it's a big number, right? So what is 2 infinity squared minus 4 infinity? Infinity still. Yeah. Did you guys buy that argument that I just made? So again, if you just think of like a big number as a proxy, so maybe instead of it, infinity, I just use like, e to the 8th or 1 times 10 to the 8th. Oops. Ugh, come on, computer.
How come you don't put the negative 1 to the
The negative 1.
like on the left? Yeah.
So I'm doing on the, what do you, on the,
You know how you put the negative infinity in?
yeah?
No, like how come you don't put the negative?
I did. I just simplified it in my head.
Oh.
So 2 times negative 1 is 2, minus 4 is negative 2, plus 1 is negative 1. I just did it in my head. Yeah, no, fair question. I did it quick and I probably didn't say very clearly. Yes, Nolan.
Would you have to do all the stuff of like plugging them into the equations? Because when we just know the negative 1 in the bracket to infinity, that's going to be found out what the lowest point was.
So this is another one of those, it depends on the directions type of problems. What is my syntax? You didn't like that? Oh, that's why I didn't like that. So again, this is just illustrating that if I have infinities, 2 infinity squared minus 4 infinity, that's still infinity, right? Like it still got bigger. But Nolan's question was like, Mr. Kulik, if I have the graph right here, what the heck am I doing monkeying around with all the stuff you're doing right now? Why can't I just like look at the graph and write down the range, because I can clearly see what the range is just by looking at the picture? Who says yes? Like, yeah, like why can't I just do that? And my answer to you would, you could, depending on the directions. So if the directions say to do this algebraically, that's what we're doing now, is doing it algebraically. If it just says find the range, looking at the picture is fine. Are you happy with that explanation? I know it's kind of a crummy explanation, but that's what I'm going to give to you. Is that okay? Okay. Olivia. Of course. Okay. Here's the beautiful part about this. If I do R2, it is the same thing. Oops. Except what did we have here? Oh yeah, okay. So again, this is just going to come out to the exact same thing. So guess what my range is? If I union two identical things together, just itself. Nolan?
You have to write the plus sign for 5.
No, I always do because it helps me remember to make sure I write the negative sign. But if you write infinity or plus infinity, it's the same, means the same thing. I just like to do it because it gets me used to like making sure I write the negative. Just Mr. Kulik's habit. You do not need to do that. Sophia. Happy or not happy? Did I answer your question of like what happens if it does both?
Yeah.
It's like, oh, it's a lot more complicated, but it's like, oh, it's not really that bad. Okay. So the lovely part is, as Nolan pointed out to you, is this relatively easy to check? Because if you have the picture, you can look at the range from it, and then you're done. You know? All right. Okay. Yes, sir. Sure. Section 1.3, continuity. Well, that took a lot longer than I thought it would, but that's okay. It's important that we do it well, right? Or that Mr. Gulick makes a big mess of it and takes longer than he needs to. It's okay, guys. What does it mean for a function to be continuous? Not that it never ends, because you can draw something never-ending that is not continuous. In fact, we've seen stuff, right? Like if you talk about a simple rational function that looks like this, that doesn't end, but it's not continuous. And you can have something that ends that is continuous. So what do we mean by continuous? You could draw the graph without having to pick up your pencil, right? Just one pencil stroke, you should be able to draw the graph. If you have to pick up your pencil to do it, ain't continuous. Does that feel okay? So the points at which a function is not continuous are called discontinuities. And there are three types, two of which I assume you have seen in Algebra 2. Does anybody remember a type of discontinuity? So a vertical asymptote would be one. This is also known as an infinite discontinuity. That'll come back on in a second, I think. There it goes. Okay, great. Should we draw a picture of that, or do you guys remember what those look like?
Let's draw a picture.
Okay. So we have something like so something like this. Y equals log of x minus 2 is got a vertical asymptote there at 2. Christian, certainly. Another would have been from the same chapter on rational functions. It's a removable discontinuity. No, didn't do it last year. That's okay. So a removable discontinuity is a situation where you just have like a hole in the graph. So this could be minus. So that's an example of a graph that has a removable discontinuity at 1. Is everybody okay there? And the third type would be a jump discontinuity. So what does that look like? Maybe something like that, where you have two pieces that are not connected together, but it's like you broke the graph and you shifted it up or something. So what does a graph, or what does a equation for a jump discontinuity look like? You might have something where, okay, we do so when x is less than or equal to 0, the graph does x minus 2. And then when it's greater than 0, maybe we have like, you do 4x plus 3. But there's like a jump in it, right? So that's in it. Those are the three types of discontinuities. At this point, all I would need you to do is be able to look at the picture and identify what the discontinuity was, what type it was, and like where it's at. Is that okay? So like here, vertical asymptote or infinite discontinuity at x equals 2, removable discontinuity at x equals 1, jump discontinuity at x equals 0. That's enough. So I think now at this point you guys can do up through 10. No, 12.
No.